A peculiar feature of space, one described with delight by its messenger, is the exclusion in the performance of its expansion and contraction phases. If you saw the spring of space stretching, you could not see it simultaneously contracting. This mutual exclusion was due to the impossibility of the forces acting to cancel each other out completely, which would happen when they reached the position of rest of the spring of space. This detail forces us to think about the possibility that the messenger, the cosmic background radiation, is taking the place of the center. Simple harmonic motion, performed by light, is composed of two phases. It is usually represented in the mass spring set. When the spring was stretched, the force would point towards the rest position, or in the opposite direction to its stretch. When it contracted, it would still point to the rest position, and there would also be an inversion in the direction of the force. Thus, it is concluded that the expansion and contraction movements would exclude each other due to the rest phase. When described by light, these movements would become virtually continuous. As long as one was there, the other would disappear. The tendency towards the resting state of the spring of space would need to remain suspended to infinity, for if it were reached, it would lead to relative motion to total collapse. This position of rest of the space spring would be equivalent to that of a flat and static universe, which is not observed in practice. So, at least from our point of view, space would have to remain curved forever. When space, energy and dark matter are left outside spacetime, everything that happens inside time is a secondary reflection of what happens outside it. That would be the case with gravity. There could not be a phase of contraction of the visible universe that directly involved space. The relative contraction would occur inside when the space stretches less outside. Potential energy would be governed by the same principle. It could only shrink in here if at present space were stretching or curving less outside. Movements that involved increasing the curvature of space, sometimes more or less, would explain why the universe would be so dynamic. Meanwhile, the messenger from space, cosmic radiation, seems to keep the universe plastered by observation and under the dominion of circular and uniform motion. If things went according to this model, space-time would be a kind of prison for the observer's mind, not his physical body. Cosmic radiation would be preventing us from being able to interact with the real universe in a direct way. This is what the uncertainty principle predicts. If there were no measurable time outside the universe, information carried by light would be made available to us with a delay. The light would be being packaged in the process of forming the curvature of space until it could express itself to us in the form of a photon. Time would only start moving when the light spreads close to the observer and space suggests contracting inside. It would be the contraction of space that would allow us to think about the possibility that time would have reversed the direction of its arrow, starting to expand within our visible dimension and apparently pointing to our past. In fact, with space out of context, it would seem to contract in here, just because it would be stretching less on the other side. Or, in other words, just from our point of view, space would be cloistered in a place without time, continuously losing curvature and tending to its two original dimensions. The theory of relativity predicts that when space stretches, time should contract. If it contracted, time would dilate. In the process, the slightest contraction of time during the expansion of space at an earlier moment would be confused with its own relative expansion in our past, or within the space-time. For those who evaluated gravity from the center of our observable dimension, it would be accompanied by a continuous drop in potential energy and a continuous acceleration of motion. Time, in turn, would be continually dilating towards our event horizon. The relative dilation of time would support the functioning of our memory, providing access to information carried by the space messenger. They would account for the expansion and increase in curvature of space outside the real time of the event, as the time prior to the scattering of light is totally unknown to us. Physicists know this because of the limited speed of the cosmic messenger. But, interestingly, they assume that inflation is occurring in real time. Maybe yes, maybe not. After the inversion in the direction of the arrow of time, when this arrow would have started to point continuously to our past, the formation of the curvature of space would appear accompanied by a secondary acceleration of the movement between the galaxies. It is assumed that this acceleration would be a consequence of the drop in potential energy resulting from a small stretching of space before the inversion of the arrow of time. If things really happened like this, whenever we talk about space contraction and time dilation, we should replace the expressions with lesser stretching of space and lesser contraction of time. Of course, this would only be possible for someone who could assess events from outside space-time. As this is impossible, science concluded, with the help of the space messenger and its Doppler effect, that the universe would be expanding continuously in the presence of constant acceleration of the movement of galaxies. In the figure of the balloon inflating, in which we painted some points on the rubber, representing the galaxies, science postulates that in the expansionary phase of the universe, they would move away from each other with ever-increasing speeds, without, however, abandoning their original positions. It would be the space around them that would be stretching. Despite evaluating the expansion with a delay due to the limited speed of light, physicists assume that it would be occurring in real time. If the stretching of space were negative, as it would during the formation of a black hole, it would transiently retain time. Information about the increasing curvature of space could only be made available by delayed radiation and after the specular inversion of the arrow of time. Thus, we could postulate that the galaxies would be moving away in space-time only in an apparent way, since there would be no absolute motion between them. The distance was due to a decrease in the curvature of space, of which there is no news. That is, for those who evaluate from its center, the universe would apparently expand inside, because space would be losing curvature in real time on the outside. The gradual loss of curvature of space, if it really existed, would also be linked to a gradual loss of the density of the total mass of the universe. As space tends towards its two original dimensions, time should gradually dilate, with this tendency being suspended to infinity. This would be a situation supported by our memory, which depends on the continuous dilation of time. The apparent continuity of the flow of time would create a very serious problem, as it would have led us to think that the light waves emitted by galaxies would be continuous. On the physical plane, this dependence of the movement of light in relation to time is used to delimit the limits of our event horizon. It's just that light and cosmic radiation are the only tools available to make this measurement. If elastic potential energy were to increase continuously, accompanying the increase in curvature of space and inflation, sooner or later the universe would collapse in on itself. If it were to shrink without the control of time, space would tend to flatten, and the universe would tend to expand forever. In both situations, the space would tend to its resting position, in which it would end up being neither stretched nor contracted. This should not happen, because, in both cases, the contraction and the complementary expansion of time would have been suspended to infinity. Thanks to our memory, supported by continuous time dilation, the universe would just be tending towards its position of static equilibrium, which will never be reached. In short, the universe can and should be static at its origin. However, it could only manifest to us if it were in continuous and relative motion. This movement would only become possible in the presence of measurable time.